Our speaker this evening, Alyssa Davidge, is a second-year master's student in the integrative biology department at the University of Colorado, Denver. Prior to returning to school, Allie was a condor biologist at the Peregrine Fund, managing the California condor population at the north rim of the Grand Canyon. She has also spent several seasons as a technician, banding terns and plovers for the San Diego Zoo's Conservation Research Institute. She's also conserved spotted owl populations in the Sierra Nevada mountains, and also has monitored migratory birds for Hawkwatch International and the Cape May Raptor Banding Project in Washington, New Mexico, and New Jersey. Her current focus is on smarter policy decisions for the future of conservation and biodiversity. After Allie completes her master's, she hopes to become a Colorado Parks and Wildlife or U.S. Fish and Wildlife, U.S. Geological Survey wildlife biologist with a raptor focus. Allie, we're pleased to have you as our speaker this evening.
Thank you so much, Bill. I'm happy to be here. Well, thank you all for being here with me this evening. I'm really excited to talk to you all about Cooper's hawks in Denver and how redline neighborhoods relate to where they end up. As Bill had said, I was a biologist for quite a while before coming back to school. And what brought me to working with the birds in the city was that I worked in traditional conservation contexts and was really frustrated by the stories that I was hearing and the things I was seeing about the species I was managing. And I read a book about urban raptors by Clint Bowl that really inspired me to look at how we can make cities a more accommodating place for wildlife. You all know probably at this point that the majority of the world's population lives in cities, and cities are growing and expanding. And so it's really integral that we ask ourselves these questions about how we can accommodate biodiversity and wildlife in an urban context. So I'm going to be presenting a little bit of my master's thesis for you today. This is a photo of a female Cooper's hawk that I took this past summer during field work. So first thing, this is what I'm going to be talking to you about. So on the left, you've got a bunch of helpful little cartoons of Cooper's hawks in case you're wondering how to distinguish them. Most of you are probably super familiar with Cooper's hawks because they are just about everywhere, but they do get mixed up with sharp-shinned hawks pretty often. And I usually use their brow line as a way to determine the difference in addition to their size. But today I'm going to talk to you about a little history lesson first about Denver's neighborhoods and redlining history in general. And then I'll tell you about urban Cooper's hawks and how they tie in. And then I'll talk to you about my specific research and what I did to try to get at this question of how we manage the urban environment and what it's doing to the placement of wildlife. And I'll share some things I discovered with you so far. And then I'm going to answer any questions you might have, and I have sources if you're interested. So the first thing I'd like to do is I'd like to give you a little bit of context for why redlining, right? It seems like a really interesting issue to attach to wildlife. And so I'm going to start kind of from the Great Depression and go on from there. So redlining is a practice that was pretty much ubiquitous across cities in the United States. And it began when the Great Depression started putting pressure on homeowners. With the creation of the New Deal in 1933, that created the Federal Housing Administration and the Homeowners Loan Corporation, which is the entity that valued neighborhoods and cities. And these little dots on this map show you the area of that city that was given a specific designation. So the dot in red shows you about how much area was redlined. And then we have a couple other grades I'll go into detail about in a minute. But New Deal creates the Federal Housing Administration's Homeowners Loan Corporation. And this is where you started to see federally backed mortgage lending happening. So in an attempt to stabilize the economy, the federal government started giving out these mortgages, but they wanted to be very picky about who they went to. So by 1939, the Great Depression ends, but we're still kind of reeling from that. And finally, the HOLSC has valued almost every neighborhood in every major city. And so now there are these values assigned to all these neighborhoods, and the technological revolution begins. So this is where we start building infrastructure. This is where we start curating our cities to look a bit differently than they had when we first started the Great Depression, right? So we're starting to build highways. We're starting to, update neighborhoods. These sorts of things are happening. And we continue this way for making decisions based on the value that the neighborhood received until about 1952. And that's when finally the Homeowners Loan Corporation is retired. It's hailed at that time as a great success for getting people mortgages. But we actually continue managing our neighborhoods the same way, considering all of those valuations until the 60s, 1968, when the Fair Housing Act was passed. That made racial discrimination in housing and loans illegal. And so it wasn't until the very late 60s when we actually stopped managing neighborhoods this way formally. And then, of course, by the 70s, climate activism started connecting redlining and ecosystem services together. So we started noticing that ecosystem services that were integral for people's health and well-being were missing from some of these neighborhoods, and disproportionately so missing from redlined neighborhoods. And I'd also like to stress that this pressure went in both directions. So we made redlined areas worse, but we also made the areas that received federally backed mortgages better. And so we've exacerbated the disparity between some of these neighborhoods. And ecosystem services are crucial, right? So they do a lot of things for us between cleaning water, cleaning air, preventing flooding, preventing illness. In Denver, especially, ecosystem services function as a form of revenue. We get a lot of tourism from the ecosystems that people like to go visit and experience. And so they have a dollar value, right? These ecosystem services are valuable. And so for some neighborhoods to have disproportionately less than others is a pretty big deal. And so now you might be wondering what these colors are. So I've got this table for you all. And essentially, I wanted to highlight that this is an explicitly racist policy. So when the HOLC started designating these things, the criteria was literally upper middle class white neighborhoods received federally backed mortgages more often than not. White and US born neighborhoods sometimes receive federally backed mortgages. It was a pretty decent chance. And then definitely declining neighborhoods that contained immigrants or people from Europe or working class folks, they had a very low chance of receiving federally backed mortgages, and hazardous neighborhoods actually received almost none at all. They were actively discriminated against and considered bad investments. And so these neighborhoods considered undesirable were designated based on who lived there. And at the time, that was undesirable populations such as Jewish, Asian, Mexican, and Black families. And so this is written right into the code. I am not paraphrasing. This is exactly what the table looks like. And so what this means for Denver specifically, I'll show you a map of Denver in a minute. But I'd like to show you some clarifying remarks when they valued parts of Denver's neighborhoods. And these kind of justify why they graded a neighborhood as a good investment or a bad investment. And so the first thing we've got is for parcel A5, and anything that's designated as A, that's going to be one of the best neighborhoods. So this is a neighborhood that was likely to receive mortgages. So south of 4th in this area is the exclusive country club. I think a lot of you who live in Denver probably know where I'm talking about already. The older part of the country club is that west of High. Although some of the structures are 25 years old, the area seems to maintain its character, being a concentration of the social elect. North of 4th and east of High is the exclusive Park Lane Square District, created 10 years ago. So 10 years prior to valuation around the 30s, by purchase and demolition of cheap houses, many of which were occupied by people of color. So they created this good neighborhood by getting rid of homes that were owned by people of color. And so that's what made a good neighborhood. This is what made a hazardous neighborhood. So this area is D13. Anything designated as D is a hazardous valued neighborhood. It is old. It is an old brick section with a reasonably large number of well-kept newer houses. Interesting. Why is this graded so low? Mostly occupied by people of color. It is not a typical people of color area of cheap, tumble-down, ill-kept shacks found in Eastern and Midwestern cities, but all of the colored occupants are housed in brick structures, either detached or in terraces. So this is like a nice neighborhood with homes, a flourishing people of color community, and they don't like it because it contains people of color. So for a community like this, it is very well kept up. Were it not for the heavy concentration of people of color, much of it would be rated C. So it would have actually been valued higher had people of color not lived there. And so this is really important to know because we also know that a lot of those other ecosystem services that are missing are disproportionately impacting people of color. And so we can see that this did happen in Denver as well. This is a map of the historical categories given to Denver. So right in the center, that is the heart of downtown Denver. So the Platte River runs through there. We got Confluence Park. And you can see that all the areas right around the tightest pack of the city are actually designated as hazardous. D13 is in like the northeast part of downtown. And so we've got a lot of this like hazardous neighborhood area concentrated right around the Platte River. And then kind of as you leave the pack of the city, you start to get better grades, right? Until we get out to like basically to the east of Colorado. And then you start to see the green there. That's the neighborhoods rated best. So these neighborhoods were more than likely going to receive federally backed mortgages. The blue, again, that would be the still desirable neighborhoods. And then the yellow would be the definitely declining neighborhoods. So these are neighborhoods that were unlikely to receive federally backed mortgages. And what really struck me when I saw this, I was looking for a way to research Cooper's Hawks, and I just happened to be looking at this map with my partner, and I realized that this probably has a lot to do with the way that our resources are allocated in this city. And Climate Safe Neighborhoods is actually interested in investigating that on behalf of people. So I'm going to show you a few of their story maps to help you kind of draw that connection between the resources that we were willing to put into the city and then the natural resources and how they've just ended up collecting in certain places. So the first thing that Climate Safe Neighborhoods did here is that they rasterized this. So they just drew boundaries around the neighborhoods and the colors correspond with their grade. Okay, so that's what that looks like. The county of Denver is outlined in black. And then all of these little neighborhoods and their values are listed in here. So Again, the red is hazardous. The yellow is definitely declining. The blue is still desirable. And then the green is the best neighborhoods. Okay. And again, you can see that downtown Denver area right here in the middle. So keep an eye on where all of those things are. And I'm going to show you a few maps of some of the land cover in the city. And you're going to see some patterns emerge when you look at them, which is what happened to me the first time I saw them. So first thing I'm going to show you is Climate Safe Neighborhood took 2011 National Land Cover data of tree canopy cover. And so the greener an area is, the higher the percent tree canopy cover. The whiter an area is, the lower the percent tree canopy cover. And you'll notice that there's very little and sparse tree canopy cover in the red areas. And then some light tree canopy cover in the yellows, and a lot of dense tree canopy cover here in the blue and green areas. And so I saw that immediately, and I'm thinking about birds, and I'm thinking, well, I have a guess as to where the birds are going to end up if this is the kind of resources that they're working with. And so I'm going to show you percent impervious surface next. And this has almost the inverse relationship that the percent tree canopy cover had. So you can see that the grayer something is, the higher the percent impervious surface of the area. So right around all of those hazardous polygons there's a lot of impervious surface, right? Almost 100%. And that's a problem because we have all sorts of flooding issues, heat issues related to impervious surface. And without tree canopy cover to kind of mitigate some of that stuff, we're going to start having a lot of negative impacts from it. So we've got a lot of this impervious surface in the hazardous neighborhoods. Let's look at the others. So there's mild amounts in the definitely declining neighborhoods. But then when we get out into the best and still desirable neighborhoods, there are very few of those polygons that contain much impervious surface at all. I mean, they contain like the necessary amount for roads we see here, but as far as the rest of the city goes, that is below average. And so there are very small areas that were designated best and still desirable, but you can see that there is a big difference between those and the redlined areas of the city. The next thing I'm going to show you is the heat measured at ground level for these neighborhoods, and it should make some logical sense, but it's actually quite shocking. So this is measured at ground level, but you can see that the areas that are red, especially the really intense red, those are up around 136 degrees Fahrenheit. And that's their average summer temperatures between 2016 and 2018. And then as you go out into the green and blue areas, there is this blue that is around 61 degrees Fahrenheit average summer temperature. You can see City Park right here. That has a low average summer temperature. Sloan's Lake has a low average summer temperature, right? All of our parks show up pretty blue, right? And so this is a difference of like greater than 70 degrees Fahrenheit. And we're talking about the same county, right? So in Denver County, the average summer temperatures at ground level vary almost 70 degrees, more than 70 degrees in some places. But again, it should be no surprise given what we've seen from the percent tree canopy cover and the impervious surface, where you have a lot of impervious surface here between the red line categories, but not a lot of tree canopy cover. That is where our temperatures are the highest. And likewise, the opposite is true for the best neighborhoods over here. They have a lot of tree canopy cover and not a lot of impervious surface. And so they have lower average summer temperatures. And so what Climate Safe Neighborhoods cares about, and what I'm going to show you next is a pretty bright and colorful map, but what they take this and do with it is that they decide what neighborhoods are in need of some climate justice aid. So they will go to these neighborhoods and provide assistance when they think that these neighborhoods are disproportionately impacted by the climate created in the city. And so I'll show you the map that they create. It's a lot to take in, but it's slightly zoomed out, but it's still looking at the same area. We've still got our polygons, but you can see they did a heat vulnerability assessment of all the neighborhoods. And so they decided, based on the incidence of heat-related death or illness, which neighborhoods suffered the most from those. And no surprise, it is sitting right along the redlining areas. And then additionally, they decided which neighborhoods were most likely to suffer from flood damage. And again, that's likely related to our impervious surface, right? Because we don't have anything collecting the water and keeping it there. It's all headed out somewhere else because it's hitting the impervious surface and not able to percolate through the ground. So you can see that the places that are most significantly impacted by not only heat-related illness, but also flood, sit right in between the red line categories here. So this is the most densely packed part of the city. And it's also the place with high impervious surface and low tree canopy cover and high average summer temperatures, right? They also break apart just what's, what areas are most likely to be impacted by heat vulnerability issues, and then which neighborhoods are most likely to be impacted by flood, if you're curious. But you can see the worst of the worst is really packed right in the center of the city. Now, this all matters for people, of course, but it also matters for Cooper's hawks. Obviously, Cooper's hawks need certain things to live in the city. And I've been super curious about how plastic their behavior is, given that they have new challenges in the city that they don't have outside in exurban areas with a lot of trees and space. But Cooper's hawks, most of you know, but for those of you who don't, they're a medium-sized diurnal forest hawk in the Accipitaridae family. They have these long banded tails, which you might get to see in another photo. But they, at adulthood, have this like black cap on their head, usually develop red or orange eyes, and then they have this orange belly, and then these black, sort of grayish black wings. And they are notorious backyard hunters. So anytime you have a bird feeder and you have something terrorizing it, 9 times out of 10, it's this guy. Their generalist tendencies lend themselves excellent to colonizing urban spaces. So they're ubiquitous in a lot of places across the United States. But lately, they've really done a good job of colonizing the city. And we've started to document that. The earliest anecdotal documentation of Cooper's hawks in the city was 1890. But over the years, we've seen a huge uptick in their population in the city. And so there are several things that are beneficial to the birds in the city. And then several things that they actually have to deal with in terms of risk in the city that they wouldn't maybe have to deal with outside. And so the first thing is, while the average distance to the nearest neighbor, so the nearest neighboring nest, is about 3 kilometers in exurban spaces outside the city, breeding pairs will nest as close as 200 meters from one another in cities. This is amazing. I didn't believe this when my advisors told me this. I have one advisor who works on Cooper's hawks in Albuquerque, and they nest 200 meters from one another. And I said, this is impossible because they are an aggressive and territorial species, especially when they nest. But they actually do nest this close to each other. And the reason that we think they're able to get away with that is because there's a huge abundance of prey species here. And so in the city, we have a whole bunch of these invasive species. We have starlings, we have feral pigeons, we have mourning doves, and a bunch of invasive house sparrows. And because there are so many of them, the Cooper's hawks do not need as much territory for foraging or other activities. And so they're able to kind of shrink that territory that they will defend during nesting season. And they're also highly successful at delivering prey. Oop, I went back, sorry. They're highly successful at delivering prey compared to their exurban counterparts. So they don't need to forage as aggressively. And then also because we actually put a bunch of ornamental tree species here, in the city, we like to decorate, with nice trees, deciduous trees, trees that may have some wildlife value to them, especially when you consider kind of how disparate the eastern part of our state and our county is. We have the prairies that come in, and then there's not a lot of big trees out there. And when you first hit Aurora and then you start moving into Denver, you get this huge influx of these ornamental trees we've planted. So we've created this good environment in a lot of ways for the birds. And then some of the risks associated with living out here in the city is that birds that have been studied in the city tend to have higher rates of trichomoniasis, which is a type of infection that is usually fatal to birds, and higher disease transmission rates because they live so close to each other, much like people, right, in the city. But what's interesting is that the hawks have kind of developed a resistance to trichomoniasis in the city, and they are less likely to die of it than their counterparts, probably because they're so frequently exposed to it. But the risk is still there. Additionally, another risk that they face is just the anthropogenic activity that affects their behavior. So they have to avoid windows, cars, predator control, and several new behaviors have been documented in urban Cooper's hawks, such as extra-pair paternity, meaning that they have more than one pair watching over a nest, and earlier nesting. And we believe this is related to less food insecurity in the urban environment, but no one has explicitly tested this. So what I decided I wanted to do was figure out how they're using the city. So I conducted surveys of nesting Cooper's hawks living in inner city Denver through the summer of 2022. And my specific objectives were to determine whether patterns of nesting territory occupancy can be best explained by redlining grades. And this is something no one has tested. Identify habitat features that may be disparately represented in the urban landscape across these grades that could influence the distribution of Cooper's hawks. And then offer recommendations for types of habitat that would benefit the retention and success of wildlife if targeted by more equitable management practices. So to connect how historically segregationist housing policy influences nest site selection of birds of prey today, it's really important to ask ourselves how these resources are being allocated across the city, like we had just seen. So this is what I ended up doing. This is a map of my study area. So I created this grid, and each point in the grid, each place where all of the cells join together is 200 meters apart. And so we have a 400 meter squared cell size, and that's about the size that a Cooper's hawk uses in the city, believe it or not. It sounds incredibly small, and it is, but that's all they need. And so I created this grid, and then I did what's called a stratified random sample. But basically, I wanted to compare the difference across these redlining grades. So I specifically designed my random pools of points so that I pulled 40 points from each grade. So I pulled 40 from green, 40 from blue, 40 from yellow, and 40 from red. And I had a total of 160 points to survey over the summer. And then I visited each of those points 3 times to get an estimate of detection probabilities. So if you go and you see a bird, and the next time you don't, and then the next time you do, you can kind of estimate how good you are at finding the bird once you've visited 3 times. So once I had my points, I set out to look for the birds. And so every time I approached a point, I scanned the area and listened for a Cooper's hawk for 5 minutes. So I allowed a kind of a settling period where I was quiet, the car was turned off, and nothing but the ambient noises around me were going on. And I used my traditional hawk watch scanning, which is you go up and down, in your field of view, and you move slowly from left to right or right to left. And I would do this in 100 or 360 degrees across around my point. And I would look for the bird. I'd also keep a close ear out for any noises that sounded like Cooper's hawk calls or juvenile calls. And I did that for 5 minutes. If I didn't hear anything or see anything, then I'd play a Cooper's hawk call and continue to scan and listen for an additional 5 minutes. And this is a big deal because since they're territorial, they are known to come to calls. So if they were within earshot of this call, it's very likely that they were going to respond, especially the time of year that I went out. So I purposely went out. You can see my timestamp there, but I started surveys in the middle of June and I ended them in the middle of August. So this was when they had already chosen their nests. They were likely beginning to fledge young. And so there are different periods when they first settle down and nest in the beginning, they're actually quite boisterous because they're developing a perimeter around their territory. And they are looking for potential competition or other threats. And then they kind of quiet down. Once they lay their eggs, they're quiet for about 40 days or so. They sit on them. And then at the very end of that, they start to become a little more boisterous again. And they have juveniles now to take care of. So they're actually very easy to hear and see if they're there. And so that was the area I was targeting, the time of year I was targeting. And so after that, if a bird did come, I would document the age, sex, behavior, and nest location if I found the nest for any birds that I found. This guy is really cool. So he was one of my first birds. You can see it was on June 21st, I guess. But this guy here is an adult male Cooper's hawk, but he has a really interesting nose to him. And this actually, I learned a while later, I took this photo of him. And this is a genetic not defect, but a genetic predisposition that some birds have to grow this additionally long sort of sharp nose piece. And so apparently he contains this gene. He's a wild bird, so he would naturally wear that down. But I guess that I consulted with my colleague at the museum, and he assured me that this is very common actually in a lot of populations of birds. So this is super cool. He was a really cool dude. But anytime a bird came to the call, or I heard a bird before I played the call, I would document all of this information about them. And just in case you're curious, you can turn down your volume if you don't want to hear it. But this is the CAC call that I played. And so you can hear it for yourselves. I've heard it a million times at this point. But I would play this pretty much on repeat for the whole 5 minutes until I got a response or until the 5 minutes ended. So I'll play that for you here real quick. And so I would play that on repeat over and over for 5 minutes to see if anybody showed up. But that is a very traditional territorial call. So if there were any birds in the area that felt like this was an invader, they were going to come and respond to that. And often I would hear them respond with the same cadence. Too far ahead. There you go. All right. So once I had this behavior, I know this looks like a lot, but don't worry. Once I had the behavior noted, I took it to this table here. And basically this is adapted from the Colorado Breeding Bird Atlas. So I'm sure many of you are familiar with the Atlas, but essentially they get observers to go out and look for birds, and then they put the bird's behavior in these categories. And then based on those categories, we get a rough estimate of how many birds are around and breeding in the area of certain species. And so I made this table species specific. And I wanted to categorize it to figure out exactly how likely it was based on their behavior that they had a nest. I found several nests just like simply by being out there and looking for them. But my advisor encouraged me to think of a lot of the other behavior as also a sign that they were nesting nearby. And I think that was a good move because ultimately a lot of those nests are difficult to see. We're looking at nests when there's a bunch of leaf on trees, and they do prefer a lot of elm species here in Denver to nest in. And so it can be quite hard to identify and locate a nest, even if you are very close to it. So this ethogram is what I used, and I took the probable and confirmed categories here of behavior. And those are the ones I used for my survey. So if my analysis. So if a bird was exhibiting any of these other behaviors, I did note it, but I didn't include it as an occupied territory. Only if the bird exhibited a probable or confirmed behavior did I decide that it counted as an occupied territory. So then the next thing I had to do was take all this information, this presence absence data. So I was out at every point 3 times, and I either saw a bird or I didn't. And if I did see a bird, I had data. And then I had to model that. So I created an occupancy model. And essentially an occupancy model has 2 major questions that are part of the equation. You have to decide what impacts the chances of an observer detecting the hawk if it is there. And so for me, I decided that visible distance, date and time, and noise levels were things that might impact my ability to detect the bird. And then also what impacts the chances of a hawk occupying the area. So whether I'm out there looking for it or not, is the bird going to be living here? And so these are the things I decided were important to birds living in the area. So obviously, because I wanted to test redlining grade, that was a big one for me. But additionally, I figured they need nesting trees. So tree resources are a big one. I measured that by taking that % tree canopy cover measurement, much like the one we looked at in the map. And then vegetation that supports common prey. So we know that the prey items of Cooper's hawks are associated with certain types of vegetation and certain types of housing density. And so there are a lot of mourning doves that are negatively associated with a lot of vegetation, but positively associated with high housing density, which is interesting. But we know that that impacts the prey availability. So I wanted to make sure we measured that. And then competition with other Cooper's hawks. So I mentioned that they are territorial, and likely there's a limit to how close they're willing to nest to one another because of that competition. And so I did measure nearest neighbor to see if the distance to their nearest neighbor had any impact on where they were nesting. And then area covered by buildings was my way at getting at building density. It's a little tricky in the city because we have these really large, like industrial buildings, which are technically one building. But if you just measure density of buildings, that building is kind of like low scored for how much impact it's having on the surrounding environment. So I chose area covered by buildings instead to address that issue. And then, of course, some combination of vegetation and buildings related to how we use the land, right? So, you know, there's a big difference between how much vegetation and buildings are going to be in a industrial area versus how many are going to be, how much vegetation and how many buildings are going to be in like a park, right? So there's quite a lot of differences. So I went ahead and I solved for all of these things as covariates, which means that they may be predictors of whether or not I detect a bird or whether or not the bird is occupying the area. And I ended up with some maps, so I will share those with you. And the one on the left here, this is that same study design map I showed you, except now I've showed you where I found birds occupying a site. So there were more birds occupying the best neighborhoods, the green areas, and fewer birds occupying especially the definitely declining area. There were 2 nests or 4, I think total, that I found in the hazardous area. And that's actually a bit more than I ended up finding in the definitely declining areas. So in yellow, I think I only found 1 nest. And so it was the lowest grade actually. not the hazardous areas. But remember that this grade is only one step away from hazardous. And additionally, some of these hazardous areas, because they were never given resources for development, we've kind of let them go back to being a bit more wild, if you will, a bit less mowed, a bit less manicured. And in some cases, that might be able to support more Cooper's hawks than we expected. But you can see the filled in dots are where I found an occupied territory, and then the hollow dots are where I surveyed but did not find any occupants. And then the kind of buffer area around those dots is the presumed core habitat area. So this is where I was taking all of my other measurements about building density and tree canopy cover. They were coming from that core use area. And then over here, I was really curious about trees specifically because I knew those would be super important to the birds. And so I did a little cluster analysis in ArcMap, just like mapping out the resources from a layer that I got from land satellite data. And based on that and the County of Denver data that I got this map. So these are still the same points over on the left map. Occupied or unoccupied and core habitat area. But the areas in pink here are unusually high values for percent tree canopy cover that are surrounded by other unusually high values given all of the data in the city. So these are big trees or lots of tree canopy cover surrounded by others. And you can see there's a whole lot of occupancy, occupied territories around this, which of course makes some sense. And then the white is not statistically significant. So there is no surprising amount of tree canopy cover. It's pretty normal given the data set. But then this blue area is statistically significant low values of percent tree canopy cover that are surrounded by other really low values. So this is areas where we have virtually no trees or surprisingly small trees considering what is normal for Denver. And of course, I put these two next to each other so that you can go ahead and look between them and make your own conclusions. But I did also connect them down here for you. And so the low values of percent tree canopy cover, this is the contribution of those grades to that area. So 95% of the cells that have low tree canopy cover are in the hazardous grade. And then definitely declining has about 5%. And then there are no areas of statistically low percent tree canopy cover in best or still desirable neighborhoods. And then on the other side, we have high values of percent tree canopy cover surrounded by other high values. And we can see that the majority of the contribution there is in the best neighborhoods. So most of the best neighborhoods are contributing to the high values. And then still desirable is close behind it. So that's our blue neighborhoods on this left picture. And then definitely declining is actually shortly behind them, but there is almost no contribution, 1%. From the redlined areas. So that tells a story for you. The next thing I did was a few more tree comparisons and then the punchline of the occupancy modeling that I did. So on average, the percent tree canopy cover in that 400 square meter cell was around 22.84% when there was an occupied territory. And on average, it was 16.47% in an unoccupied territory. So there's some threshold there that is less ideal for the birds. And then here is your breakdown by the grade of average percent tree canopy cover. So only the best neighborhoods actually meet the criteria of average percent tree canopy cover that Cooper's hawks are drawn to or occupy more often. And then the best category is just below that threshold. So the average is 19.38% in the still desirable neighborhoods. In the definitely declining neighborhoods, 15.8%, is the average percent tree canopy cover, and then 8.26% is actually the average percent tree canopy cover of redline neighborhoods. And then down here, I'm showing you the results of my surveys. So I detected birds most often in the best neighborhoods, which should surprise no one. And then we see that dip I was talking about earlier in the yellow neighborhoods there, where I didn't detect many birds. But then because I detected so few, very few were occupied, of course. But the rest of this trend makes a whole lot of sense. So even though I detected similar amounts of birds, in the still desirable, the blue and the red neighborhoods, you can see that fewer were occupying the red neighborhoods, which means they were probably likely hunting over there and then going back to live in one of these other areas. So the odds of detecting a Cooper's hawk, if it was there, was about 45%. So I had a 45% chance of seeing a bird given it was there. And then the odds that the bird occupied any given territory I surveyed was about 20%. And then I ran these models. So AIC is a way of comparing the equations I talked about earlier. So I drew up these equations that basically competed all of these theories against each other, saying, oh, tree canopy cover is the most important feature to the Cooper's hawks, or redlining grade is most important to the Cooper's hawks, or vegetation mixed with buildings is the most important thing to the Cooper's hawks. And overall, the model performed much better when I added the redlining category, which means that there was an effect of redlining on Cooper's hawk occupancy. And then hawks prefer to nest in areas with higher percent tree canopy cover, as I showed you. Only the best category met the needs of the hawks on average. Redlining grade and percent tree canopy cover did the best job of estimating occupancy. So when I competed all these models against each other, the two that came out on top, the two that performed the best at predicting Cooper's hawk occupancy, was when I put redlining grade in the equation and when I put percent tree canopy cover in the equation. And redlining grade brings some unique information to the models that tree canopy cover doesn't address. So even though we know that tree canopy cover differs significantly between grades, there is some other piece of information encompassed in redlining grade that is not encompassed in building density or in vegetation that the birds respond to. And so there's a lot more to dig into there about what this redlining grade could be standing in for that is ecologically meaningful to the birds. But those are the main points. And with that, I'm just going to say I want to thank, I hired 2 undergraduate researchers last summer and they did excellent work. And so I want to thank Brenda Escobar and Layla Blair and my partner Claire Harris, who all came out to help me look for birds and stood in the middle of streets playing Cooper's hawk calls. And then of course, my advisors, Dr. Laurel Hartley, Dr. Mike Wonder, and Dr. Brian Millsap, for the support and feedback as I've been going through my data. And so with that, if you have any questions, I'd be happy to take them.
Ali, thank you very much. What an interesting project you have there. Let's see what we have in the way of questions. Could you just, what were the ecosystem services in the 40s to the 60s? What are some examples of the ecosystem services you were mentioning? You did mention some of them.
Yeah, so there's a whole bunch of things that ecosystem services, the term encompasses, and it's different for every particular ecosystem. But some of the things that a lot of natural spaces do well are things that I mentioned, like purifying water, cleaning air, preventing flooding and erosion. And of course, then there's your psychological and health related services. So there's all these studies that suggest being in nature, around nature is good for us, not just anxiety decreasing, but also provides us with a better sense of connectiveness, community, peace feelings. And so, I mean, we have ecosystem services that are very hard and fast, like flooding, which is an obvious one you can see. And then the less obvious ones, like state of mind and sense of community, or illness, like preventing heat-related illness is another example. But when you have more trees, they purify the air for free. When you cut them down, suddenly you need an air purifier, right? We all kind of understand that concept.
Okay. 5 of the Cooper's hawk's nests in relatively undesirable habitat, according to your criteria, are near the Platte River. Couldn't the river attract more prey for this hawk and be a desirable nesting corridor?
Definitely. So, first of all, as I said, there is a kind of rewilding that happens when you stop caring about the property, which we have done a lot with the redline categories, right? Some of that land we've kind of let go, or we've rebuilt it in recent years to make it into some kind of a park, right? Think about Confluence Park, for example, right? The changes that's undergone since the 60s have been substantial. And so I think part of it might be prey. Definitely, my advisor has told me several times that Cooper's hawks, female Cooper's hawks, actually go to industrial areas to hunt. And I think that's because a lot of their prey, like starlings, actually do better in areas with a lot of building density and lower vegetative cover. And so it could be prey. It could be just that there's a lot more we've left alone out there because we're no longer interested in investing in it. And that can actually help birds sometimes.
Okay. And had a comment about how what a fascinating presentation you gave, and what a great combination of historical, sociological, and research and ornithological data. And somebody complimented you on your graphs, how clear that made your points. So
thank you.
Congratulations. That's wonderful. Any of the, Susan, do you have a question, or anyone else? Peter?
Actually, there's a couple more at the bottom.
Okay. Yeah. Let me scroll down.
Yeah, there's.
Let me scroll down. Yeah.
Mhm.
Thanks, Peter. Thanks, Peter. Okay. A number of other comments about how they enjoyed your presentation. Question: is it possible that higher levels of rodents or other prey may have an impact? Are you aware of any way to measure that?
Yeah, so the next frontier for a lot of this work is probably going to be digging into that prey aspect that I didn't have the capacity to measure very well, right? So I used some land use characteristics to stand in for available prey items. But my advisor and I both agree that the next frontier for this is to examine how the availability of prey is distributed across the landscape, because that definitely has a big influence on how hard these birds are working to survive. But Cooper's hawks do use other forms of prey. I'm sure the question asker is fairly aware of this, but disproportionately so when we studied Cooper's hawks in the city, they are way more likely to ambush a pigeon or a dove than even like a house sparrow. They have very particular tastes. So starlings, doves, starlings, doves, and pigeons, are their top 3. And so we have to ask ourselves where those guys live, because that's probably the biggest key to the puzzle. But I am certain that they use other prey resources in the city as well. And we should kind of do another deep dive into that and look into if rodents play a role, for sure.
Okay, and tied in with that same question is, do bird feeders in neighborhoods impact Cooper's hawk density?
Yeah, so this has been a really interesting and kind of age-old question that Cooper's hawks researchers have had, because obviously it seems to us, because we are watching, like they are disproportionately showing up at bird feeders. But really, it's just because obviously we are keeping track of that area. And if you went ahead and you counted all the times you weren't looking for birds and you saw Cooper's hawk, that would kind of even the odds. So you are looking for birds when you find a bird at your bird feeder, of course. And they do definitely prey on birds there, but there have been some suggestions that they practice kind of like a sustainable management on their prey. So some people have said that they could overhunt the feeder, right? They could overhunt the feeder and end up eating everything that would have come to the feeder. But why do that if you can allow some birds to go in and out? And this is a sustainable food source for you. You can come back to it later. And so they tend to use bird feeders in conjunction with other things. But they aren't exclusively hunting at bird feeders.
Okay. How many eggs does a Cooper's hawk typically lay in a season? And do their offspring stay in the same area, or do they disperse to new areas to occupy?
Yeah. So most of the time I see them lay 4 to 6 eggs. I think they can lay up to 8 if they try really hard, but that would be a lot to keep track of if everybody fledged. And they typically have a period right around when I was surveying at the end there in August and into like maybe early September, where their offspring are with them. So they're still feeding the offspring in August. And the offspring are very close, if not on top of the nest. So they don't really range too far. But by the time we get through August and into like mid-September, the offspring are on their own, and they will either migrate for the first time, or they will become residents and look for territories for the winter.
Okay. And Ted Floyd has a question and a comment. Ted says, Mississippi kites have nested in recent years near Martin Luther King Boulevard and 30th and Park Hill neighborhood, which was redlined. They nest where there are trees, but Park Hill is hot in the summer. Kites are moving northward as their favored prey item, the cicada, and he gives a scientific name, Megatabicin dilbatus, is spreading north, and there sure are a lot of cicadas in Park Hill. Do you think we can predict future nesting of kites with this historical data?
Wow.
Mississippi kites.
Yes. So I live in right at the edge of Park Hill neighborhood, actually on MLK. So I actually went with Peter to see the kites last year when they were nesting nearby. And it was really cool. But I mean, I think that you could probably predict what they're going to use in the city. I'm not sure, given like if they have very narrow preferences, I'm not sure if that's the only thing they eat or if they're just insectivores and they have a few options. But if you have a lot of like land that's kind of just been left, like for instance, the Park Hill Golf Course, you get a lot of insects there that are thriving. So this is an example of what I was saying, rewilding kind of the redline neighborhoods. It can cause this like boom in insect populations that could have other effects, right? Other cascading effects on the food chain. So if there's a really great food source there for them, it's possible that we could predict where they're going to nest.
Okay, and other comments complimenting you on your presentation, including from an urban bee biologist to an urban raptor biologist. And let's see, anything else? Let me check one other thing. Do Cooper's hawks tend to use the same nest or nest site for more than 1 year?
Yes. Cooper's hawks, they have usually maybe 2 to 3 nests within a very compact area. So in the city, we're talking like a cell, like that core use habitat area. They could have up to 3 different nests in different trees in that area. And they may rotate between nests from year to year, but generally speaking, that territory is held by a male all year round. And that male is usually going to defend that territory even in the winter months. So you can expect the same male at least to be on the same nest in the same neighborhood every year. But it may be that they transfer from one of their nests that's right in someone's backyard to like across the street or something like that. But unless the male dies or something catastrophic happens, they'll be occupying similar territories to what they did last year.
Okay. Another question, although urban Cooper's hawks are an alien territory in the city as a forest species, they would still naturally be more attracted to wooded, canopied areas in the city too, right? Anything in your research contradict or go away from that? If so, what might that mean?
Yeah. So generally speaking, that's what we find. Patch size is important when you have areas, large tracts of land that contain good quality trees, especially trees that could be potential nesting habitat. This is where they like to live. Even in cities, they will find those areas and concentrate on them. The only thing that I have noticed between working with my advisor in Albuquerque and here is that you do have kind of this behavior of females that no one has really looked into very much. And so they don't hold territories. They are basically cared for hand and foot while they are on a nest, and then they leave, and they will use different parts of the city to hunt in the winter or before they hook up with a male on a territory. And so those areas are like the industrial areas, and some of the like seemingly less rich in natural resource areas are the places that the females will end up using. And I don't have a good explanation for why, but my advisor has tracked several birds in Albuquerque and has found that to be true.
Mm-hmm. Okay. Does the Cooper's hawk have any enemies? And does your research indicate that they differ much in either quantity or quality in the city versus out in the more pristine environments?
Yeah, so they do, one, each other, but two, they will definitely not nest near other raptors, other birds of prey. So it is very unlikely that if a red-tailed hawk nest was nearby, a Cooper's hawk would also be using a similar area. They have some greater risks, I think, in the city of predation because we have such a high crow and raven population here. And so you can see a lot of those birds predating eggs or even attacking juvenile birds. And that's definitely one of the biggest threats they have, but also people. So when they fall from the nest, people immediately rush to their aid because they're like, oh no, the poor baby birds. And before you know it, that can get very dangerous in a city, right? Either being discovered by people, run over by a car, chased by a cat. Feral cats are something that you don't often have in the wild. So these are additional risks.
Okay. Now you had mentioned this right at the beginning, near the beginning of your talk, but review for us again, just what is redlining? What is that practice?
Yeah.
What does that consist of?
Yeah. So the practice of redlining was brought up as a way to kind of help the economy after we had a really big tank during the Great Depression. And so it was a way to get people into homes, but it was an explicitly racist segregationist practice. So they were more likely to give mortgages, federally backed mortgages and security and resources to affluent middle-class white folks. And less likely to give it to people of color or immigrants. And so what that has done is in areas where immigrants or people of color lived, it disinvested in those neighborhoods. And we have continued kind of on that legacy, but less explicitly ever since those first valuations. And then likewise, we've disproportionately managed the affluent areas, the white affluent areas, to be resource rich. Because we have gone ahead and valued them highly and pumped resources into them. And so that's really the reason that they still impact natural resources on the landscape today. But there's a whole lot more you can learn about redlining. The map I showed you of the whole United States, so that's from Richmond, Virginia, University of Richmond. And if you go check that out, it's got every state cities that were redlined. And then you can go click on any one of them and you can click on any parcel of land and you can see exactly why it was graded the way it was graded. And it's pretty fascinating.
And for our last observation is one that you made, Allie, early on, concerning the importance of looking at wildlife diversity in urban areas, since urban areas are growing such, and they cover such a big area. One of our viewers observes denser urban environments are supposed to be more sustainable for overall diversity, avoiding sprawl and maintaining habitat. So important to learn what we can do to make the urban environments more biodiverse and supportive of human as well as non-human life. I think that's an important point to stress as we close. Allie, thank you so much for a wonderful program and alerting us to what's happening with Cooper's hawks and how it's coordinated with what the effect of redlining has had on our Cooper's hawks population.